All right. Hello and welcome everyone. We are live right now. So, welcome back to this amazing lecture of differential equation and welcome back to Tutee learning. Sorry, we will tell I don't know about him. Okay. All right. So, let's start today's discussion about differential equation. So, if you recall about our previous classes where we were discussing the homogeneous form of differential equation, and in our last class we discussed about how to solve an homogeneous differential equation and how to apply the also how to solve questions of variable separable type of differential equation, right? And then we move forward to understand those general questions, right? And also we took some examples in our previous class, right? So if you please go back to the previous lectures, that is lecture number 5 or 4, you will be able to understand that we started to discuss about the solution of the differential equation, right? So in today's classes also we are going to do the same thing. We're going to discuss about that second type, that is we're going to talk about such homogeneous equations, but they won't be homogeneous at the first go, but we have to reduce it to homogeneous form, right? So let me start today's discussion of class with reducible to homogeneous form. Okay, so some of the differential equation can be reduced to an homogeneous form, right? So reducible to homogeneous form, right? So today let us first discuss about the reducible to homogeneous type of differential equation, right? So if I start to discuss about this reducible to homogeneous form of differential equation, there are multiple types to it, right? So let me start discussing about each of the type in detail, right? So let us discuss about type 1. What I'm talking about is this, that in type 1 many times the differential equation will be the differential equation specified may not be homogeneous, but some suitable manipulation is required to reduce it to a homogeneous form, right? Generally, such kind of expression of or equation involves a function of rational expression generally. Okay, so what is key over here to understand is that they generally have a rational expression. Okay, they generally have a rational expression whose numerator and denominator are linear functions. Okay, so both numerator, so I'm writing nr as numerator and dr as denominator, are linear function. Okay, so I'm writing both denominator and the numerator as both linear functions, right? Now, so what is the form of the differential equation? Generally, the form looks like dy by dx is equals to some function of a linear numerator and a linear denominator. Okay, let's write over f dash. So it's a function of some linear denominator and linear numerator, right? So that is what we need to understand, right? Now please note over here the presence of this constant, the presence of this particular constant, that is c, and this f dash, these two constant in the linear part, because if this constant won't be there, we could have easily taken out the x as common and then it would be simply a homogeneous form of differential equation, right? But because of this presence of this constant in these expressions, in this rational expression, the homogeneous form is not being appearing easily, right? So it is basically becoming a non-homogeneous form. Now, what if I try to do some substitution, or what if I try to make some transformation such that this constant vanishes, right? So my idea is going to be very, very clear that I am trying to do some substitution in terms of x and y such that the constant vanishes. How can I do that? It's very easy that if I replace this x with, let us say I replace this x with some capital X plus h, and let us say I replace y with some capital Y plus k. In this expression, if I replace this in this expression, then my function, and in this expression, then I will get a modified constant, right? So then I will get a modified constant, that is I will have a modified constant AH. Now X and Y again are variable, but H and K are constant. Okay, H and K are constant. So I'm going to tune in those H and K constants such that this particular term, so if I substitute back in this equation, then AH plus BK plus C is going to be the modified constant, right? This is going to be a modified constant, and I'm going to take it such that it becomes equal to 0. That is my first equation. That is, I'm going to make the modified constant to 0, right? And similarly, here I will have dh plus ek plus f dash. This is going to be equal to 0. So this is my second equation, right? So I will have two equations involving h and k such that my modified constant, which is basically because of the transformation, is becoming equal to 0. And if I'm able to do that, then my evaluated expression is no more a non-homogeneous form, whereas it is going to be, so this is now reduced to, so it is now reduced to, now instead of dy upon dx, it is going to be d capital Y upon d capital X, because again, now this won't be making any difference, because if I take derivative of small x, then this is going to be, h is going to be, and h and k are both constants, so it's going to be 0. So I can write this to like this, and this is now going to be a function of this expression, like a capital X plus b capital Y divided by d capital X plus e capital Y, right? So now this is going to be an reduced expression like this. So now this is basically having a reduced expression, right? So this is now having a reduced expression. Okay. So now if you look carefully at this expression is going to be, a homogeneous form of differential equation, right? Which can be easily solved by understanding that part that is we already saw that in our previous class, right? I hope this is clear. Now this expression is clearly homogeneous. So this is reduced to a, so the non-homogeneous part is now reduced back to a homogeneous part. So the non-homogeneous part is reduced to a homogeneous expression, right? So we will have a homogeneous expression over here, and this will be can easily solved by what we studied in our previous class, right? I hope expression is clear to all of you. I hope this is clear to all of you. Please let me know in the live chat. Is this clear? Is this clear to all of you? Please let me know in the live chat. Is this clear? Any questions? Any questions, anyone? So if you don't have any question, then I will have some question to ask, right? I hope this is clear. So let's try to solve one question to understand how we are going to apply this form over here, right? So let me give you the question. Please try to solve this question. So try to solve this differential equation, which is given as dy upon dx is given as 2y minus x minus 4 whole divided by y minus 3x plus of 3. Okay, y minus 3x plus of 3. Okay, so this is our non-homogeneous differential equation, right? So you can see there I have a rational expression with linear numerator and linear denominator, right? So please try to solve this by understanding the approach that I tried to teach in the previous part, right? So please try to solve this question. Please try to solve this question by doing the transformation, and then find out the homogeneous form from this non-homogeneous part, and then try to solve the homogeneous differential equation to finally get to the solution. Please try to solve this question. and let me know the final answer. Please try to solve this question and let me know the final answer. Uday Gaming, please solve this question and let me know the answer. Please solve this question and tell me the answer. Please try to solve this question. So the basic idea is that you have to replace the small x with the small x with capital X plus h and the small y with capital Y plus k, and you have to choose the values of h and k such that the modified constant is going to be equal to 0, right? So please try to solve in that way. Please try to find out. Please try to find out the value of h and k. Please try to solve this question. Please tell me the value of h and k that you are getting. So over here, if I put that the modified constants is going to be equal to 2k minus h minus 4, that should be equal to 0. That's my first equation. And my second equation will be k minus 3h and then plus of 3 equal to 0. So that is my second equation, right? So if I solve these two equation, solving, we will get h and k as follows. We'll get h and k as follows, right? So please try to find out the value of h and k. So you will see that h is coming as 2 and k is coming as 3, right? So if you do this, we will get this following answers as follows, right? Now, once you get h and k, then if you replace the and you reduce the differential equation, the reduced differential equation is going to be look like this. D capital Y by D capital X is going to be equal to 2 capital Y minus capital X whole divided by capital Y minus 3x, right? So this is our homogeneous form of differential equation. Now from here, if I take x as common, then this is going to be equals to the follows, and I will have, then I can take from here y upon x as common, then I can take y upon x as some variable v. So let us say it is equals to variable v, because what we did in our homogeneous understanding. So our modified, then our differential equation will be like this, that is v minus 3 dv upon d capital X whole divided by, so I should take the capital X because variable separable form. So whole divided by v square plus 5v, v square plus 5b plus 1 is equals to capital Dx upon x and negative of it over here, right? So then I have to solve this differential equation. Then I have to solve this differential equation by the Federal form. So just integrate this to get to the final answer. Okay. And please don't forget to substitute it back in form of small x and y. Okay. Because your answer is should be in basically in form of small x and y, not in capital X and capital Y, right? Because we transform small x and small y by capital X and capital Y. Okay, and don't forget to do the transformation back again when you're getting back to the original solution. Okay, so please take a note of that because generally people make a mistake over here. Okay, so your solution in place of x, it should be small x minus 2, and in place of y, it should be small y minus of 3. So this is the substitution that you need to do finally after you get to the uh, expression in capital X and Y, and then you get to the required solution in small x and y. Okay, so this is going to be my general solution. All right, I hope this is clear to all of you. Is this part clear to all of you? Please let me know in the live chat. Is this clear? Please let me know if this is clear or not. Is this question clear? Please try to solve this question, okay, rather than discussing about arbitrary things. Understanding the general concept of mathematics would be better than to discuss about all those secondary things, okay? All right. So I hope this is clear to all of you. Now, what you try to understand over here is that now this is a type 1 form of non-homogeneous differential equation which you are reducing to homogeneous form, right? But in doing so, what you are doing is that you are trying to find out the value of h and k. However, there is one sudden modification that you will understand over here is that let me discuss about the type 2 right now. Okay. So if I talk about type 2, now what is special about type 2 is that, so what you will see that is special about type 2 is that, now suppose again our differential equation is basically some function of some linear expression. Okay, like this as follows, right? So if I have a differential equation like this, now when we try to find out the value of h and k by doing the transformation, like x is equals to capital X plus h and y is equal to capital Y plus k. So when I do this transformation, I try to find out the value for h and k by putting the modified constants as equals to 0, right? So this is our general approach. So this is our general approach, right? From these two equations, we try to find the value, right? But what if this system does not yield any solution? Okay. What if this particular set of system of equation does not yield any solution? That is, it will happen that if I have these two straight lines are parallel to each other, right? So if these two straight lines are parallel to each other, then there won't be any solution, right? So if I have A upon B is equals to D upon E, in this case, there won't exist any solution, right? There won't exist any solution, right? Then in this case, how are you going to solve this question? So if I have no solution over here, then how am I going to solve this question, right? Because ultimately, after doing the transformation, I have to get back to the answer in form of the uh, original x and y, right? Also, to replace this h and k with constants, I need to know the value of the real value of the h and k, right? So that I have it as a homogeneous form of differential equation, right? But if I don't have any solution, in this case, I cannot find out the value of h and k, right? So what I'm going to do is that in this case, how am I going to reduce to the homogeneous form is that, let's say, so let's say I will assume this d upon a upon d is equals to b upon e. Let us say I will assume it as lambda. Let us say I will assume it as some lambda. Okay, let us say. Then in this case, because these two lines are parallel to each other, so this line can obviously, or either of these two lines can obviously given in form of some lambda times the other form, right? So what I'm going to do over here is that I'm going to represent the differential equation, that is of the functional form like this, to some lambda times of dx. So the numerator over here can be now replaced by some constants times the denominator, that is dx plus ey plus c whole divided by dx plus ey plus f, right? This is what I have. Now if I divide with the expression over here, I'm going to get this expression over here is that, so this suggests giving me an further modified expression is that, now let us assume dx plus ey as some variable, let us say y, okay, let us say v, okay. Then if I differentiate this v with respect to x, then if I differentiate this expression v with respect to x, so dv upon dx would be equals to d e times dy upon dx, right? This will become like this, and therefore our differential equation that we have, that was of the following form, of this form, right, of this particular form, is now reduced to like this. So this is basically like the variable separable what we also did in the variable separable form, right? So this now becomes dv upon dx minus d and whole multiplied by 1 upon e is equals to lambda times v plus c whole divided by v plus f, right? Like this. And then if we separate the variables, and then we can easily solve this question further, right? So if I then try to find it out, so my dv upon dx will be of the form as like lambda ev plus lambda ev plus ec whole divided by v plus f minus plus of d, right? Plus of d, yeah, plus of d over here. And then if I simplify the expression, the denominator is v plus f, and then I'm going to have it over here lambda e plus d. So I'm taking v part common plus ec plus d, right? This is my modified form. Now I can take the variable separable form, so I can club the variable with v. So v plus f times dv whole divided by lambda e plus d times of v plus ec plus d, right? And that is equals to dx, right? And then I can solve it easily in the variable separable form, right? So integrate to get the answer from here, right? Right. So integrate and solve the final result, right? So integrate and solve the final result. All right. So I hope this is clear to all of you. Is this part clear? So from here, just integrate to get to the final solution, right? Is this clear? Is this part clear to all of you? So let's try to solve one question based on this particular type so that you can understand how to solve these kinds of question. Okay. So please try to solve this question and tell me the answer. I have already mentioned you the following algorithm or the steps. All right. If the step is clear, then please try to solve the problem. Okay. Please try to solve this question. Please try to solve this question. That is, I have the following differential equation that is given as dy upon dx is equals to x plus 2y minus 1 and then x plus 2y plus of 1. Okay. So this is a non-homogeneous form of differential equation where I have the where I have, that is, the ratio as constant. Okay. The ratio of a upon d is equals to B upon E, right? From the previous example that I discussed, or the previous discussion of type 2. Okay. So please try to solve this problem and tell me the answer. Please try to solve this question and tell me the general answer. What will be the general answer? Please solve this question. Please try to solve this problem. Please try to solve this problem and tell me the general answer or general solution. Please try to solve this problem. Aditya Soni, what do you mean by no? Aditya, can you try to solve this problem? What is wrong? Please check the discussion that I discussed about type 2 integral. Try to understand the discussion and please try to solve over here. Just assume that x plus 2y as some v, okay, and then you can proceed. This is simply a variable separable type of form of equation. Please just use the form that is x plus 2y as equals to v, okay. Please replace x plus 2y as v, okay. Then only you will be able to solve this question pretty easily. All right. So let's try to see the solution. So from here, if I assume, first of all, if I look at this expression over here, this expression and this expression is similar in both the numerator and the denominator, right? So if I assume x plus 2y as some v, so if I assume x plus 2y as some v, then dv upon dx is equals to 1 plus 2 times of dy upon dx, okay. Then this is going to be of this form over here, right? Right? Is this clear? So what I'm going to do over here is that I'm simply going to replace this with a reduced form. That is, I will have over here as, that is, dv upon dx minus 1 and whole divided by 2 is equals to v minus 1 by v plus 1, right? And if I simplify the expression, so I'm going to get dv upon dx is equals to v minus 1 by v plus 1 whole multiplied with 2 and then plus of 1, right? So this is going to be of this form, right? And further, if you simplify this, this is going to be like this, and now I can solve this easily by variable separable form. So from where, so then you just integrate both the side to get to the solution, right? So if you just integrate both the side to get to the solution, you will see the general expression. So you can solve this very easily. It is simple expression over here. So if you try to solve this expression over here, so this will be equals to, and please don't forget that to put back v as x plus 2y, right? So don't forget to put this back into the following form, right? So this is basically going to equals the general solution in terms of v. First of all, it is going to be equals to v plus 4 by 3 times natural log of 3v minus 1, and then is equals to 3x plus some constant c, right? And if you just replace that with the v with x plus 2y, the final general solution or expression is going to be y minus x plus 2 by 3 times natural log of 3x. So over here I will have 3x plus 6y minus of 1, and that is equals to 3x plus some constant, right? Sorry, this will be equals to only some constant, right? Yes. So this is going to be the general solution, right? This is going to be the general solution. I hope this is clear to all of you. This is going to be the general solution, okay? Is this clear? Is this part clear? This is going to be a general solution, okay? This is going to be a general solution, okay, which represents a family of curves, right? This represents some general solution which represents some family of curves, right? Is this part clear? Is this part clear to all of you? Please let me know in the live chat. Is this part clear? All right. So if this is clear, then I think we are probably done with the homogeneous form of differential equation, right? And then we also understood about the type of differential equation which is reducible to homogeneous form, right? And there we analyze two important things. First is when I can find the value of h and k by doing the transformation. But in certain cases, the solution of equation may be yielding no solution. In this case also, how I'm going to solve that question, that is also been shown over here, right? Which is simply by the use of the variable separable form, right? All right. So I hope this is clear. So if this is clear, please try to find the solution for this homo problem. Okay. So if this is clear, I would like to all of you to please work on some homo problem. That is the homo problem. Please find the equation of curve through the point, that is passing the point 1 comma 0 and satisfying the differential equation, okay, and satisfying the differential equation that is given as y dy upon dx plus 2x whole square is equals to y square plus 2x square, and then multiply it with 1 plus dy upon dx whole square of it, okay. So please try to solve this differential equation. It might look very difficult at the beginning, but it's a very simple problem, okay. Just try to apply your brain, okay. Just try to apply your brain and try to find out a solution in terms, trying to find out first of the differential equation in terms of first order differential equation, okay. It might look very odd that it is a differential equation of first order and 2 degree. The degree is 2 over here, second degree. So try to reduce into such a form where you can solve the first order differential equation with first degree, right? So please try to get back to that equation and then you try to see that which of the following solution is satisfying 1 comma 0 to finally get to the exact equation of the curve, right? So here please try to solve this question and then you will be able to, and also please let me know the solution in the comment section of this particular video after this live is over, okay. So after this live class session is over, you can always let me know the solution, okay. So I hope this class is clear to all of you. So this is a homework problem. So please take a screenshot of this problem and try to solve this problem. Try to solve this problem and let me know the solution in the next class. Okay. So the next class, when we're going to meet again tomorrow, we're going to discuss from this question itself. Okay. I hope this class is clear to all of you. I hope this class is clear to all of you. So I hope you have enjoyed studying this class as much as I did in discussing the solutions and the concepts, right? So in our next class, we are going to discuss about the linear differential equation of first order. So first order linear differential equation and how to solve linear differential equation of first order, that is going to be discussing in our upcoming lecture, that is lecture number 7, that is going to happen tomorrow, right? So in tomorrow's class, we're going to start with discussing about the linear differential equation of first order. So with this, I thank you for all of you for your attention and your time, and I wish you all the best, and I hope you have enjoyed watching this session as much as I did in discussing the concepts. So please take a note of all these concepts that I am discussing right now in this class, because this is going to be very, very useful for your JEE Mains and advanced examination. Okay. And if you're into this particular platform, please share these videos with your friends, as well as subscribe to the channel and also hit the bell icon. Okay. So that whenever we are live on this particular platform, you obviously get a notification, right? So with this, I would conclude my session of